Hi everybody, I'm Mikhail, and I want to show a little bit of EXAPUNKS. So this is a game that came out in 2018, and I just finally started playing it. It's a Zachtronics game. Zachtronics, they make games that are, they primarily make games that are about like open solutions, where there isn't like a very specific solution that exists to a puzzle. You just kind of come up with something, and then if it works, then you get to compare it to what other people have done, and see how your solution performs against other people's. But yeah, so there's no like, there's probably some perfect solution that exists for like every problem, but it's about being creative and coming up with something that works, and then like optimizing it over time. So in this game, you program these little things called EXAs, and I'm actually going to go through a couple of solutions that I've already written, just to kind of show how the game works and explain some of the things before jumping into trying to come up with a solution on the go. Let me see here. So restore file, find and retrieve. I'm trying to pick like a good one to yeah. So let's try this one out. So in this solution, let me open up. Okay, so the task was to erase guest's debt to the copy shop by zeroing out his balance in the customer database, which is located here in file 200. So that's the customer database, and then appending a payment to the payment log, which is the file 201. That is that has today's date and the exact amount of the prior balance. The customer ID is available in file 300. Now I have this booklet that I've gotten, which is okay. So the game comes with these two zines that ostensibly show you how to play the game. There's also PDFs that come with the game itself, so you can just look at the PDFs, but they highly recommend that you either print the PDFs out or buy the zines, so that you have a physical copy to refer to as you program your EXAs. And EXAs are shown here. Think of them as like little programs, little robots. Well, I mean, they're programs, but they're visualized as like little robots inside this space. And this is the space of the computer. You have these different hosts, and they're collected by these links that you can traverse, or that your EXAs can traverse. And then you also have these different registers. So each EXA has a register, has these four registers, X, T, F, and M. I'll explain later like what they mean, but F is for reading to and from file, M is for communicating with other EXAs, X is for storing values and retrieving them, and then T is also for that, but T has a special significance because when you test the value of something, then the result of that test gets written to T. So if you store anything in T, it ends up getting overwritten when you use a test command. So let's run through the actual like programs here. I have my primary EXA here, and what it's going to do is it's going to grab the file 300. It's going to copy. So let's run through. So it's going to grab that file, and it's going to copy the value from that file into the X slot, and then it's going to drop it and traverse to the next host using the 800 path, and it's going to go through and copy the different like parts of the file into slot T, because the only way to advance the file pointer is to like read or write to the file. So what I'm going to do is I need to advance to a particular line with this within this file, and the way to do that is by looping through and reading values, storing them in this temporary slot until finally I get to the one that actually matters, and this is done with like fjump. So what happens here in this line is if the result of this condition check is false, then jump to the line that's labeled loop 200, and then if not, or if the condition is true, then just keep going. So here it's going to go through and check, and here it found a match. So what it should do is, instead of jumping back to the line that's labeled 200, loop 200, it's going to go and it's going to retrieve the two values that come after that ID and store them, or not store them, but it's going to transfer them to the other EXA that I have, which is XB, and that EXA is the one that's going to remember them by writing them to its memory. So I have XB. So this whole time it's been here in the home host, and it's been waiting to receive some information through the M register, and it's going to do that. So it sent the value, so the EXA sent the value to the register, and here it received it, and then I'm zeroing out. So I have a line here that says seek -2, so that it tells the file pointer to go back 2 spaces, and then I just realized I could probably, instead of looping through every single value, I can do some skips in here and optimize the solution a little bit. So let's actually try that after I kind of show this first thing. Okay, so I remembered the dollars and the cents. Also, the way to know like what the different files are is there's a page within the zine about like not transactional, but about where is it? Digicache. Okay, so the customer database, usually file 200, stores a list of customers with 3 values for each customer: the customer ID, dollars owned, and cents owed. So that's how I knew that those 2 values after the customer ID would be the dollars and the cents, and why I needed to store them. So as the task asks me to do, I need to write today's date, then customer ID, and that particular balance as if it was a payment. Because the whole idea behind EXAPUNKS is like you're writing these programs to hack the system. Like you have certain tasks, and then you're trying to get one over on the like corporations and government. So back here on the copy hashtag date T, so what happened there is I grabbed the date from the date register, which always has the current date, and I put it into the temporary slot, and then I moved back, and then the first thing I did was append that retrieved date to the payment file, and I've then received the dollars and the cents from the other EXA that, like, this whole time, like, all it's been doing is first it was waiting to receive that data, and then it started waiting to send that data. Then it got that, and that's it. And now we're going to go through like all these different runs, and it's going to show me the performance. So I'm comparing myself to Jacqueline, and she did really well. So what you want to do is you want to have fewer cycles, and she's managed to basically use up half the cycles that I have, which is pretty cool. So I'm going to see if I can maybe optimize this a little bit. So one idea was to use the seek command to maybe like skip. So at the beginning of the loop, first we're going to copy FT, and then so the first thing it's going to be the customer ID, and then after that it's going to be 2 spaces of stuff that we're not actually interested in. So it doesn't. We're not interested in checking that. So if we do seek 2, what that should do is it should skip to the next line. Yep, skip to the next line. So now that should actually lower the cycles because it's doing fewer checks. Oh, okay, something bad happened there. So seek 2. So why did it fail? Oh, okay. So now I actually need to change. Actually need to go back 2 spaces there. There we go. Okay, so that should work. Ooh, okay, so that substantially improved the solution. So now I'm getting closer to whatever Jacqueline did. Well, for now, I'm just going to return to desktop and move on to the next one. So another thing you can do is you can like use math, use like very kind of basic mathematical arithmetic operations. Here, the goal is to write the message that's contained in the file 300 to the traffic sign, and the way that it works is when you're writing things to the to the data register, which is responsible for what appears on the sign, that thing first waits for the also this is the part of the zine about that. So first it waits for the row specification, then the column, and then the character. And the file here only contains information about which characters should be printed. The idea is that these appear in sequence, so it's going to be, first character, second character, third character. The sign is 3 rows by 9 columns, and so you need to kind of keep track of which position you're writing the character to, so that you could tell that to the data register. And the way that I've solved it is by using the modulo operation and doing subtraction and division. So let me walk you through how that works. So this is the goal. This is what the sign should look like when we're done writing to it. So let's walk through. So first I'm going to get the file. I'm going to traverse to the next host. I'm going to clear. So when you write to the CLRS register, it clears the sign. And then I'm going to do modulo 9, store the result in the temporary slot, then subtract that from whatever the value is. Basically, I'm trying to get the remainder, I'm trying to remove the remainder so then I can divide. So this was 0, and first it copied the data, and then I'm going to increment the counter. So the counter is X. That's where I'm storing like the kind of overall counter. So it's going to be it's going to go from 0 to 26 because there's 27 positions total because it starts from 0. And this checks whether we've reached the end of the file. If not, then we'll go back to the line labeled right line. We're going to go through, and just to show you like what happens after a few of these steps. So we're at 5, then we're going to subtract 5 from 5. It's going to give us 0. Divided by 9, I mean it's 0. So what here, all I'm doing is I am figuring out which row I'm supposed to be in. Am I supposed to be in the first row, second row, or third row? And once we get to 9, so 8 is the last like position on the first row. Once we get to 9, that should actually be the signifier that, hey, we're now on the second row. Okay, so divide by 9, that gives us 1, or modulo 9, I mean, okay. Anyway, this works. Like, I think it's because like I'm writing to data, as opposed to writing to somewhere where we can like visualize it. But this works. So that's EXAPUNKS. There's another solution that is really cool, and I believe. Oh wait, no. This is, here it's very interesting because you've got this file where you have to find the keyword, and that's going to be at the very end of the file. After the keyword, it's going to tell you where data starts in this tape backup, and the next number tells you how long. Like the length of the data. So in this case, it's going to be 55th number. It's going to be the start of the data, and then it's 18 numbers after that. That is the entire data belonging to this particular keyword. So you kind of have to like first traverse to the correct tape host, and then find like where the data is located and how long it is so that you can properly copy it. It's a really interesting one. I believe this is the one. Okay, so this one is super cool. This is the solution, or like problem and solution that made me feel the coolest and the smartest when playing this game so far. The idea here is, okay, you've got in one of these leaf nodes, there's going to be an EXA holding a file. You're going to want to find that and then bring it back to the home host, and it's going to be different every time. So you can't just like program it to go a very particular path. You have to write a program that specifically finds it and then brings it back. So what I've done is I've created an EXA that clones itself and sends the clone one way, like to the left, and then it goes to the right a certain number of times. So I like specify a depth of the tree, or no, I track the depth of the tree and then limit it to a certain depth. And then I tell all the EXAs to like grab a file, and then they all check whether whether they're holding something essentially, and all the EXAs that aren't holding a file, they end up self-destructing because you're not supposed to leave a trace when you do these like little hacks. And then I make the one EXA that actually holds the file. I make it go back to the host. So let's actually see what that looks like. So here it's going to test whether it is at the leaf node depth of the tree, and if not, then it's going to clone itself. It's going to send the clone through link 800, and it's going to go through link 801, and each of these is then going to perform that exact same kind of loop of checking what, like how deep they are in this tree, and if they need to make clones of themselves, then they will. And then we're going to do this one more. So now everybody is on the leaf nodes, and then they're going to first attempt a kill operation, because you can't grab a file that is being held by another EXA, but what you can do is you can destroy another EXA. So this is like, in this case, the EXA that I'm going to destroy. And then grab the file. At this point, all the other EXAs self-destructed because they didn't have the file. And then this EXA is going to traverse back to the host. And I was using the same counter that I was incrementing before. Now I was decrementing it until finally we get to the host, and then we drop the file and we terminate. And then we do this a whole bunch of times and see how we rank against everybody else. So in this case, yeah, I did better than Jacqueline, but I did much worse than a lot of other people have. So somehow there's actually, so this is the histogram showing like other people, like everybody else who has played this particular puzzle, and in this case it looks like people have figured out some really clever solutions where they're mostly getting like 30 cycles on their solutions. So now that I've done that, let's figure a solution out from scratch. How many receipts do you think a normal human being could enter per minute, assuming average conditions? No idea. So this is like a AI that you talk to, and it brings you... Okay, so the conceit of the game is you're playing as someone who gets this disease where your body just starts to like become a computer, but it's not cool. Like it just eventually you become like a lifeless mechanical husk. But there are certain tasks that you end up doing where you're like hacking your own body, which is pretty cool. But yeah, and so this AI is giving you medicine, giving you this special drug to slow down or to like pause the infection. But in order to get more doses of it, you have to keep doing these. You have to be like writing these hacks. Okay, so locate Ember 2's user file in the user's host and overwrite it so that the sum of the values is the same, but no individual value exceeds $75. Oh, I picked the wrong one to do. All values except for the last must be... you know what? This is... I'm gonna back out of that one. Cause multiple automated teller machines to spit out cash. Dispense all available cash from all connected ATMs. Interesting. Dispense all available cash from all ATMs. So there's 5 ATMs total. And the way that this works is, let's read about it. Okay, DigiCash, accessing data, warehouse, Equity First Bank. ATMs, and then at the back of the network, you'll see a number of ATMs connected over dial-up connections. Equity First ATMs only dispense $20 bills, so the cash register tells you how many bills are remaining. Okay. If you write 20 to the dispense register, it will attempt to dispense a bill, but if the ATM is out of bills, it'll send a failure message that alerts the bank, so be careful. Interesting. I'm supposed to just dispense all available cash from connected ATM, so I don't actually appear to have to concern myself with these. It's all about just sending out the EXAs to dispense all the cash. Okay, and each of these has a different number of $20 bills available. So I'm thinking, first I'll send the EXA over to here, and then I will make So what I want to do is write like a generic kind of program, and then clone the EXA, and then all the clones can just go here and then dispense all available cash, and then upon the dispensement they just self-terminate. So first let's start by going down the path. Wait, is that okay? First here, then here, then here. Okay, so it's only going to be 3 links. After that, it's going to be 1, okay, 0, 1, 4, 5, 6. Is it going to be the same every time? Oh no! Oh gosh, it's going to change every time, so I can't just program it. Okay, so it goes from 0 to 6. Oh, interesting. Huh. I don't think I've ever tried actually going across a link that hasn't been specified. So what happens? Okay, link ID not found. It just kind of terminates. Okay, so I'm gonna have to be smart about it. There is a section in this book about like, not troubleshooting exactly, but it's like little hints of, hey, here are like the common issues you may experience with the EXA, and here's how to get around them. Invalid link traversal. Say you were looking for a specific link, the EXA that tries it will terminate, but now you know the link isn't there. Sensing a pattern. So maybe what I can do is, okay, so an EXA will try to traverse a link, but then if the link's not there, then it will terminate. So perhaps I can create, once I reach this platform, I can create 6 other EXAs and have them go to like all the different links, and then some of them will error out, but then other ones will succeed, and it's the other ones that succeed where they'll actually do the work. So I'm still going to go here. So once we reach there, how should I do this? I'm going to first copy 800 to the X register. So it's going to store the link ID in the X slot. mark. Okay, first let's increment it by 1. So each clone is going to increment by 1. Then later down the line, I want to say navigate, or navigate. Sure. Link X, so it's going to traverse. I like it. So it's going to traverse across the link where with the link ID that it has stored, and each clone is going to have a different ID. And then one of them is going to have to the original one. Well, no. If I started at 799, then the original one will just go down the 800 one. Yeah. So I'm going to first test whether X is 806. If it's okay, then if jump clone. Wait. Okay, so I'm incrementing by 1. Then I want to replicate. So I should actually do the test at the very beginning of the loop. So test 806, and then if true, or test if less than 807. Wait, no. Okay, copy. Okay, so starting with 799, we want to increment that first thing. Once we've incremented it, then, because what I want to do is I want to, oh wait, no, actually, oh, okay, I don't need the other clones to create subsequent clones. I can just have the very first EXA clone itself. So REPL navigate. I think that's the correct command to use. REPL should be the one that, yeah. And so the way REPL works is you give it the line where once the clone is created, where should like its program start essentially. And once we've created that clone, the clone is going to start here and it's going to navigate to the ID, the link ID that was stored, which should be 1 greater every time. So that's going to be the original one for the clone. So we're going to change this back to 800. And then going to do that. Then after it's done there, we want to test if X is 806. Oh no, yeah, 806, because that will be the last clone that it should do. So if that's false, then go back and make another clone. But if it's true, if it's true, then subtract 6 from X and store the result in X. So in this case, what we're doing is changing the 806 back to 800 so that it could navigate, and then it's just going to go through the loop. Okay, so let's just see that that works. yeah. So everything works there. So once it navigates to the ATM, it needs to dispense all available cash. Each one has a different amount of dispensable cash, so we can keep track of. So first we're going to copy, first we're going to copy from cash into X, and then mark dispense. We're going to check if X is 0, and if it is, we're going to terminate. So if X is if X is 0, then going to terminate, because we don't want to do anything at that point. We're going to halt. Okay, otherwise keep going with this. And first, how did it work? It's like you're supposed to write a value to the dispense register. Okay, if you write 20 to the dispense register, it'll attempt to dispense a bill. Okay, so copy 20 to dispense, then decrement X, and then jump back to dispense. Okay, so let's just walk through. Okay, so it's going through. Everything's good. Everything's good. Everything's good. Okay, cash is being dispensed. Okay, so what I'm waiting for now is waiting for the second ATM to reach 0 and for this exit to terminate once it reaches 0. Again, the other ones are going, so let's fast forward. It works. Everything's dispensing. Oh, I really wonder what the distribution of cycles is going to be on this one. I don't know. I feel like this is probably a good solution. Oh, geez. Wow. Okay. Huh. Wow. Okay. So people have figured out way more optimal solutions here. So I'm in the... Okay, I'm at the top here with, well, bottom really, with how many cycles my solution took. Well, that's pretty cool still. So that's EXAPUNKS. It's a really cool game. I hope you enjoyed watching me solve this problem just like live. Yeah, I cannot stop glowing about it. It's really cool. I like how it makes me feel cool, inspired. Like, yeah, I do programming at my job on like a daily basis, but I don't know, there's still something like really cool about kind of applying that kind of thinking to the game, and in this particular context of like, I don't know, feeling like I'm hacking things. Yeah, so that's EXAPUNKS. Cheers. Stay safe and healthy, folks.